Welcome to MFC Group's FasTech Seminar series hosted by Mel Foster, EAS Sales, FH Sales, and TMC. Thank you for joining us today. We're presenting Automotive Memory Solutions with ISSI, and our speaker for this seminar is Bruce Schwartz. Bruce is the Senior Director of North American Sales for ISSI and has been in the semiconductor industry his entire career, working in production, marketing, and sales. And Bruce is going to introduce the rest of his team to you as well. Everyone is muted, so please type any questions that you may have into the meeting chat, and we'll monitor those questions throughout the presentation. And at the end of the presentation, we will do a Q&A session. And with that, Bruce, I will turn it over to you.
Hi, everyone. Good afternoon. So basically, I'm just going to do a brief introduction of ISSI. And then will be followed by Flash, Anand Bagchi, who's the VP of Flash Marketing, DRAM, which is Charles McLaren, who is the Director of DRAM Marketing, and SRAM, Aaron Batista, who manages the SRAM Marketing Group. And then at the end of the presentations, we'll have a session where you can answer or ask any questions that you have. So basically, we were a company that was founded in the mid-1980s. We were fabless from day one, and we still are today. And by the way, is the model of the semiconductor industry today. So we've been in business a long time. Our strategy is to support the automotive and industrial marketplaces, which consists of 75% of all our revenue. Automotive alone is worth 50% of all the business we do. We have a broad portfolio. We support ISO 9001, 14001, and ISO 26262. And we make legacy DRAMs, DDR, DDR2, SDRAMs, DDR3, DDR4, and all the low power versions. And we'll get into the details of each of these. SRAMs, which is high speed, low power, synchronous, and Flash, which is NOR Flash, Octal, Parallel, SLC NAND, eMMC, UFS, and MCPs. So this is our automotive customer base. And you look at this customer base and you go, why do all these customers want to use ISSI? And the question becomes, because every one of these customers, having dealt with us in a long period of time, knows that we'll support their product for the length of an entire automotive cycle, which is usually 2 to 3 years from a design point of view and 7 years of production. So you have to be able to support automotive for 9 straight years. And though there are other good suppliers in this industry, none of them can support product for 9 years. So we've been in the automotive market for about 25 years, shipped some 2 billion units, and our quality and long-term product support are critical to what the automotive customer is interested in. Our corporate infrastructure is driven by stringent automotive quality requirements and knowledge gained by being in the automotive business for 25 years. We have a broad offering in SRAM, DRAM, and Flash with temperature ranges from -40 to 125. So what do we say when we talk about long-term support? So we want to minimize the need for capital is what we look at. And our long-term product cycles means that there are few PCNs that the automotive customer has to deal with, a customer-driven strategy, and a high mix. So from a long-term point of view, we also look at cost effectiveness because you never have to redesign a board because you're going to still be able to get our parts on a long-term basis. And it doesn't mean that we never put any new rev on a device, but we'll continue making parts that are form, fit, and function for right now our roadmap say 2032, and next year it will say 2033. We have high qualities. We drive towards 0 ppm from automotive grade products. product is in place to achieve PPB levels at right now. And we have yield flags and early life failure tests, rigorous product tests. And from a competitive pricing point of view, very broad portfolio, so you can get all the types of products you need, but DRAM, flash, or SRAM. And it reduces the cost of end of life issues and supports multiple memory technologies. So, what is an auto grade part? Every automotive part gets extended dynamic burn-in, 100% test across the full temperature range. Every lot is every that comes out. There's an early life failure rate that's pulled on every lot, and if it doesn't pass, it is not used for automotive. Obviously, we support PPAP. We're AEC Q100 qualified. We have strict test limits for cream of the crop parts that we're using. We target 0 ppm, and our temperature ranges go from -40 to 125 C with long-term support. And you can see how that compares to a standard commercial and industrial part that you get off the shelf. So from an automotive application point of view, we look at body electronics, end controls, ADAS, digital cockpit, infotainment, and connectivity. And when you look at each one of these end applications and you look at the product lines, these are the types of parts that we support that are used in each one of these applications. And then from a cluster, body electronics, safety systems, EV infrastructure, we have the type of products across the board that are going to be used in each one of these applications. So what we do is we work with the micros that exist out there as our partners, and we work on reference designs that our parts are used in these reference designs that you'll be able to say you have a processor and can say, oh, this part has been working with that processor, and then you go in with a sense of security about what your application and how that's going to react. So right now, it'll be Flash and Anon.
Okay, thank you, Bruce. So quick overview of ISSI's Flash products. So the first table that you see highlights our serial NOR products. So when we say serial NOR, it's SPI or QSPI as commonly referred to in the industry. Two flavors of those products available in 1.8 volt as well as the 3 volt variants. And as you can see from the density offering that we have, so we go as low as 512 kilobit and go as high as 2 gigabit. So basically a very wide range of very low density to very high density of serial NOR flash products that we offer. And then as you can see, for some of the higher densities, starting from 256 megabit to 512 megabit to 1G and 2G, those products we started introducing inbuilt ECC feature as well. So because of the ECL requirements, some of the auto customers has been pushing us to implement ECC, and I think later on we have a slide on ECC. So basically, most of the products in ISSI we have incorporated built-in ECC to help with the whole ASIL process. In addition to the standard QSPI products, we have also introduced something called Security Flash or RPMC. So this is kind of a standard which was driven by Intel a while back, and now quite a few chipset is adopting this RPMC. So basically, between the host and the flash, there is like a handshake mechanism. There is some hashing algorithm used and passing of token to make sure that the no outside agents elements is able to access the flash. So that's the whole concept of the RPMC security flash, and for that also we have multiple densities in offerings. Some are the low densities are about to sample, and the higher densities 128 and 256 megabit we are already in production. Next, let's talk about the octal flash. No, Bruce, go back to the or XSPI or octal flash. So this is among the new standard that has evolved in the QSPI in the NOR flash world. So it's from a by 4 we go to a by 8 configuration with octal, so 8 IO lanes, so which instantly doubles the bandwidth. And in addition, the frequency for octal flash has gone up to 200 megahertz double data rate, so that gives a 400 megabytes per second bandwidth on the interface. So this is getting a lot of traction and a lot of new designs in automotive, various applications, as well as many industrial applications. We are seeing huge adoption of XSPI or octal flash, and we are probably the only one in the industry who's supporting very low densities like 32 megabit, 64 megabit, and all the way up to 2 gigabit. So again, a wide range of densities being offered. So in addition to the QSPIs, we also do support the legacy parallel NOR flash. And another interesting product that we offer is MCP, which is a combination of octal RAM, octal flash, or hyper RAM octal flash. So both these products, the RAM and flash, they shared the same footprint. So a lot of space constrained designs. Customers would say, oh, if we can have a single footprint for octal RAM and flash, whereby we can save some board space and helps in routing on the board, that would be great. And that's where this MCP concept comes in. So as you can see, we have various combinations of densities of RAM and flash that we offer in this MCP product portfolio. Next slide, Bruce. In addition to the NOR flash products that we just discussed, we also have NAND and managed NAND products. So when we say NAND, the first product that we have there is the SPI NAND. So it's basically similar to SPI NOR that we talked about earlier, but it's a NAND flash with serial interface. So a lot of designs we are seeing which are requires high density of boot and code and logging requirement, like 1 gig, 2 gig and all. NOR flash may become cost-wise prohibitively expensive, and also NOR flash 2 gig is kind of the max that the industry offers. So that's where we are seeing a transition to serial NAND, and we do offer 1 gig through 8 gig various densities of SPI NAND. In addition, the SLC parallel NAND, which has been in the industry for a long time, we do support that as well, from 1 gig to 8 gig. And then the other product which is getting widely accepted and we're getting a lot of traction is the eMMC. So we do offer both the 5.0 and 5.1 versions. We have low density eMMC products like 8 and 16 gig using ML2D MLC NAND, and higher density eMMC products from 32 to 128 gigabyte using 3D TLC NANDs. And probably we are the only one in the industry today who's supporting both the 100 ball BGA and the 153 ball BGA. 100 ball came earlier in the industry, and it has 1 millimeter ball pitch, so it was quite popular in a lot of industrial designs, medical applications. But then industry moved towards the 153 ball package with 0.5 millimeter pitch. A lot of auto industrial customers, they don't like the 0.5 millimeter pitch, but because most of the big names have moved to 153 ball support, there's not very much support left for the 100 ball, and that's where we come in. And if you have a 100 ball design, BGA design with eMMC, we'll be there with you for the next 7, 10, 15 years. And the last product, which is the newest in the family, is the UFS. Two different UFS versions that we are supporting, the legacy UFS 2.1 and the UFS 3.1, the newer standard. There are a lot of existing designs where customers using UFS 2.1, and again, not much support left in the industry for that. And that's where again ISSI comes in to help you with supporting that UFS 2.1 products for again next 10 plus years. So for UFS, 64 gig is our starting point, and we are offering 64, 128, 256. And if there's a need for higher density, we can discuss with you separately and can offer higher density UFS products. Next slide, please. A quick update on the eMMC. As I was mentioning earlier, we have two different flavors. The lower density eMMC using 2D MLC NAND and the higher density using 3D TLC NAND. So for the 8 gigabyte and 16 gigabyte eMMC, we also offer something called a factory pre-configured pseudo SLC mode offering. So by which basically all we are doing is we take this 8 gigabyte eMMC and set it pre-configured in the factory to PSLC mode. So then the effective user available density becomes half. But then your endurance becomes 10x. So from 3000 program error cycle, you get 30,000 program error cycles. A lot of applications, they are very write intensive and they do care about the endurance. So those are the applications where customers, of course, you can set the PSLC mode. It's we do have application note and guide you how to do it. But sometimes customers say, oh, can you please pre-configure from the factory? And that's where we offer the 4 gig and the 8 gig. The P, as you see written, it's basically PSLC pre-configured from the factory. And so basically here we just summarize the different endurance and available densities for the different eMMCs that we have. Next slide, Bruce. And then quick update on the UFS. So as I was mentioning, UFS 2.1 was our first family of product that was released. And it is supporting up to automotive A2 grade, which is -40 to 105C using 3D TLC. And we are sampling, actually about to go to production soon in the next couple of weeks. And then the UFS 3.1, which is the newer product family in the UFS. That one we are sampling right now. Probably in next couple of months, we should be in full production with automotive fully qualified. Next slide. Next one. Okay, just a couple of high-level slides on applications. So, I mean, a lot of you are fully familiar with all of this. So as we are seeing that the trend in the automotive world is basically moving from more of horsepower driven to more of a brain power driven approach, where there is a lot of connectivity, there is a lot of advanced ADAS applications in the car. And basically those are the things that are driving a lot of adoption of electronic components, whether it's SoCs and sensors and high-end GPUs and all. And that also helping us in a way that all these whether it's a zone or whatever architecture it is, they are using a lot of MCUs, CPU, GPUs, SoCs, and also a lot of associated memories along with it. Next slide, please. So today, I think Bruce earlier mentioned more than 50% of our revenue at ISSI comes from automotive market, and it's various applications, whether it's infotainment, ADAS, or vision camera, telematics gateway, any applications we look at. We are supporting our automotive tier ones and OEMs with our DRAM products, our flash, our SRAM, across the entire gamut of automotive applications. Next slide, Bruce. This is just a battery management system slide. Actually, we wanted to highlight this is getting a lot of popularity these days. So we see a lot of customers kind of asking us for this kind of battery management application memories. I think some of you in the audience today also are designing this kind of BMS systems. So we can, again, in the interest of time, maybe today is not the right time, but maybe we can have a separate call to discuss about memory requirements and how we can help you on this. Next slide, Bruce.
Hi, everybody. This is Chuck McLaren. I'll be talking about DRAM today. Thank you for joining. So from our offering matrix point of view, we have quite a number of products for DRAMs. From the legacy SDRAM that's been around for over 20 years. We have a DDR family still being supported by ISSI, but not a lot of new designs for that. We have DDR2, DDR3, 3L, DDR4, and those span all the way up to 16 gigabit for the DDR4. On mobile, we have legacy DRAMs. We have the single data rate at 3 different voltages, 1.8, 2.5, and 3.5. Have LPDDR, LPDDR2, and the newest of the technologies, LPDDR4 and 4X. We also have some specialty DRAM, particularly of interest for networking applications, RLDRAM 2 and 3. We also have an on-chip ECC option. Just want to make sure I cover that. Could we go back to that matrix slide, please? Thanks. So the on-chip ECC option is available for certain products, including DDR3 and 3L for the 1 gig and the 4 gig densities, as well as LPDDR4 and 4X for the 2, 4, and 8 gigabit densities. We have both on-chip ECC for those densities as well as non-ECC options if you choose either one. We also have some products that are in development. LPDDR4 has the most products in development because it's so popular, being adopted for so many projects out there. And now we can go on. So for synchronous, this kind of technology, single data rate synchronous DRAM has been around for over 20 years. It's still very popular among customers, particularly because many applications don't need a high-end SoC. They might be just fine with a MCU. Sometimes needing more performance or more features, which then necessitates a DRAM. So with ISSI DRAM, you can choose whatever DRAM you need for your application, from low densities, 16 meg, all the way through 512 megabit, and also multiple components if needed. So we have one of the widest array of options in the industry, including by 8, by 16, and by 32 data widths. We also have both TSOP and BGA. The BGA is more popular these days. And then based on your temperature requirements, we have just commercial, but also we have industrial and automotive, all the way up to 105 degree. So as I mentioned, several manufacturers of SoCs, MCUs do have capability for synchronous DRAM on their MCU. We're a trusted supplier with those companies. We work with them closely to make sure that our parts are put onto reference designs and on their evaluation boards. And we also continue to reinvest in 3.3 volt DRAM. We have a new generation of synchronous DRAM based on 38 nanometer process. So as those products begin to ramp up and begin to support for new projects and also continue to support running projects, we continue to support some existing technologies. So there are products that are supported in parallel over the years. Let's go on to the next one. For DDR3L, we have a wide range of densities. If you need just a low density, we have 1 gigabit by 16 and by 8. We also have 2, 4, and 8 gigabits. Currently, 4 gig still remains the most popular density overall, but you shouldn't feel required to pick a particular density unless it fits your needs. For 16 gig, we have a stacked solution, and that allows dual rank, but allows you to fit more density into the board if you're space constrained. And one of the reasons that we still see a lot of new projects for DDR3 and 3L is that there are leading processors and SoCs that still support this interface. So it really depends on what kind of performance you need. If you can get by with a DDR3, that might be the most cost-effective choice. But if you need a higher performance memory, you might lean towards DDR4 or LPDDR4 for your solution. Let's go on to the next one. For DDR4, we have choices of 4 gigabit, 8 gigabit, and 16 gig densities. The 16 gigabit is a dual rank by 8 part. And the other two are both standard solutions. And we have by 8 and by 16 for the data widths for both 4 gig and 8 gig. Most of the applications needing DDR4 tend to be industrial or in some cases, networking or automotive. Really depends on the choice of the processor and the performance requirements for your application. Let's go on to the next one, please. For LPDDR4 and 4X, ISSI is offering a growing array of choices here. In both the single, which is the by 16, and the dual channel configurations. But we also have 4 gigabit, 8 gig, and we're working on the 16 gig density right now. Further, we're also working on potentially increasing the density choices to 1 gig and 32 gig. And those will be added over time as we prepare for those kind of solutions. We also have a new smaller package. So while the most popular and widespread usage is a 200 ball BGA package, there's a new package option from ISSI for some parts, which is the 2 gig and 4 gig single channel, and that is the 100 ball BGA. So the advantage for that would be if you have a very space constraint board and you really need to shrink that package down to a smaller size. That might be a solution for you. And one of the unique solutions that we offer at ISSI is on-chip ECC. So there are several approaches if you do need ECC. The first and most time-tested solution would be having an external ECC. So that would be a solution where you have a processor or MPU or FPGA where there's a wide bus, usually a 72-bit wide bus. You must then use multiple DRAMs across your bus, and that would mean you have a larger number of components occupying the space. And also, not all processors would support this. Some processors just support a 32-bit wide data bus. Another solution would be the inline ECC, which is a slightly newer solution where the processor is managing the ECC, just like the first solution. In this case, though, with inline ECC, it only requires 1 or 2 DRAMs. But it does restrict the choice of processor because it must support ECC. Plus, some of the space on the components of the DRAM would be reserved for the ECC bits, therefore slightly decreasing the amount of available space for the application. The third solution available from ISSI is on-chip ECC, where in this one, it doesn't require any ECC support from the processor. All of that is managed by the DRAM. In addition, we have additional ECC features that can enhance the implementation of ECC, such as a counter that can count how many errors have happened, as well as an error flag that can be checked by the processor. And this solution is being adopted by a growing number of automotive and industrial customers. Overall, this solution might not be for everyone. On an individual part basis, it might be more expensive, but as an overall solution, this actually can be more cost effective. Some of the on-chip ECC solutions from ISSI are the 1 gig and 4 gig DDR3. The 4 gig currently has an ASIL B product certification. We also have a 2, 4, and 8 gigabit LPDDR4 and 4X with ECC as well. And all these products you see here are currently in production. Thank you.
Aaron?
Thanks, Bruce. Hi, my name is Aaron Batista. Today I will be presenting the ISSI's SRAM product line. So here's an overview of the ISSI SRAM product portfolio. Starting at the top section, we have our asynchronous SRAMs and pseudo SRAMs, which are 5-volt legacy SRAMs, high-speed asynchronous SRAMs, ultra-low power SRAMs that are available from 64 kbit density all the way to 32 megabit density. And then for pseudo SRAMs, this product is available in the higher densities from 8 megabit to 64 megabit density. In the middle section, we have our low pin count RAM products. The first line in here is the serial SRAMs, and it's available in the lower densities of 512 kbit all the way to 4 megabit. The next item is our serial and quad RAM. It's offered in 8 megabit, 16 megabit, 32, and 64 megabit densities. We are looking to support the 128 megabit in the future. Then next is the HyperRAM and OctoRAM. It's currently available in 32 megabit, 64 megabit, 128 megabit, 256, and 512 megabit densities. We're targeting to offer 1 gigabit density in next year. And lastly, we have our MUX latch asynchronous SRAMs. It's primarily available in 4 megabit density at the moment. I will discuss more about our low pin count RAM products on the upcoming slides. And then on the bottom section, we have our synchronous SRAMs. The first line shows densities available for the standard synchronous and no weight synchronous SRAM from 2 megabit all the way to the 72 megabit. And then we also have Quad and Quad P, which are high performance synchronous SRAMs that are available in 16 megabit, 36 megabit, and 72 megabit densities. I also want to highlight that many of these products are available with built-in ECC feature as indicated by the ECC icon. And right here is our SRAM product strategy. We offer a complete solution and broad portfolio of SRAMs, which include the legacy, high-speed, ultra-low power, and pseudo SRAMs, ECC-based SRAMs, OctoRAMs, HyperRAMs, and serial RAMs, and synchronous SRAMs. And then part of our strategy is our commitment to providing long-term support on new parts, as well as mature and legacy products. As an example, ISSI has been manufacturing 8K by 8 SRAM since 1988, and we're committed to supporting this product until 2034. We continue to invest in R&D and other resources to support our SRAM products, while some of our competitors are exiting the market. And those are the list of new products, which include our 40 nanometer synchronous SRAMs, 65 nanometer synchronous SRAMs, 55 nanometer quad P SRAMs, 16 megabit ECC based asynchronous SRAMs, and 4 megabit ultra low power SRAMs and serial SRAMs. And then we also have buffer inventory of our SRAMs to ensure shorter lead time. Our SRAMs also feature a broad temperature support, which allows us to provide high quality products to service our telecom and automotive and industrial markets. And then moving on to the low pin count RAM solutions. So HyperRAM memory is a DRAM-based memory with a hyperbus interface. It has very low signal count and uses 8 DQ pins for address, command, and data, 13 pins for the 1.8 volt option, and 12 pins for the 3 volt option. This device supports hidden refresh operation. It can support up to 200 megahertz for the 1.8 volt option and 166 megahertz for the 3 volt option. We do offer ECC-based solutions for 64 and 128 megabit products. It features automotive temperature support. Both minus 40 to 85C and minus 40 to 105C are available for all our HyperRAM products. And then we also have minus 40C to 125C temperature support for 64 megabit and 128 megabit densities. These above features makes these products ideal for industrial, medical, and automotive applications. And then for the OctoRAM, this is a DRAM-based solution with hidden refresh and OPI or Octo Peripheral Interface Protocol. Very low signal count, 11 or 12 pins for functionality of the device, and 8 I/O pins. There is an optional ERR pin for 64 megabit and 128 megabit ECC-based products. It can support up to 200 megahertz DDR operation for the 1.8 volt and 166 megahertz DDR operation with the 3 volt option. Variable latency or fixed latency feature, burst read and write operation. It also features automotive temperature support for minus 40 to 85 and minus 40 to 105C. This is for all Octalarm products as well. And minus 40 to 125C support available for the 64 megabit and 128 megabit density. has an optional ECC for the 64 and 128 megabit, and a very small footprint, 24 ball BGA. And here's a couple of products for our low pin count solutions that are gaining a lot of interest right now, which is the SRAM and QuadRAM. Both products are available in 8 megabit, 16 megabit, 32 megabit, and 64 megabit densities. SRAM is available in the SOIC package, while the QuadRAM is available in BGA. Both are available in minus 48 to 85 and minus 40 to 105. And then the QuadRAM is also available in minus 40 to 125C for 8 megabit and 16 megabit densities. The QuadRAM also has a built-in ECC feature for the 8 megabit and 16 megabit densities. And the SRAM supports 104 megahertz speed, and the QuadRAM can support up to 133 megahertz for the 3 volt part and 200 megahertz for the 1.8 volt part. And that's it for the SRAM portion.
ISSI is a supplier. We have a strong tier 1 customer base. Our quality levels are better than AEC Q100. We can have a complete product portfolio that basically nobody else in the industry has. Our long-term support is unparalleled. In fact, there are other suppliers who've tried to come out with long-term solutions, and they're all good suppliers. However, their whole portfolio is based on a commercial customer base. So they make decisions based on a commercial customer base, even though they support industrial and automotive applications. So being able to support those on a long period of time is difficult. There's strong infrastructure support that we have for the automotive marketplace. We have great foundry partnerships that use actually our leading edge technology in order to develop their new products and processes. We have an experienced design team and management who dealt in automotive for a long period of time. And we continue to invest in this product portfolio to support automotive customers. We're financially sound, and I believe having ISSI on your print is the best insurance you have to long-term cost of ownership in the semiconductor business. That concludes our presentation right now.
If you have any questions, feel free to reach out to your field sales representative, and we'll be happy to get you any further information or answer any questions for you.